Hello everyone. Today, we are going to decode plate tectonics theory, the single framework that explains why earthquakes cluster, why volcanoes line up, why mountains rise, and why oceans keep changing shape. If you understand this properly, a big part of physical geography stops being random facts and becomes one connected system. To understand plate tectonics, begin with what is actually moving. The lithosphere is the rigid outer shell. It includes the crust plus the uppermost part of the mantle. Under it is the asthenosphere, which is hotter and behaves like a semi-fluid solid over long time so plates can move over it. Prelims trap here is predictable. Many students write crust when the question is lithosphere. Do not. Lithosphere equals crust plus upper mantle. Now separate two things you must never mix up: continental crust and oceanic crust. Continental crust is thicker, around 30 to 50 kilometers, and mostly granitic, so it is comparatively low density. Oceanic crust is thinner, around 5 to 10 kilometers, and mostly basaltic, so it is higher density. That one density line explains a lot. When an oceanic plate meets a continental plate, the oceanic plate is more likely to subduct because it is heavier. These are the major players, the big plates that dominate global tectonics: Pacific, North American, South American, African, Eurasian, Indo-Australian, and Antarctic. Also notice the ring of fire around the Pacific. In UPSC, maps are not decoration. If you can place these plates mentally, you can predict where earthquakes and volcanoes concentrate. Along with major plates, you need key minor plates that frequently appear in map-based questions: Nazca, Arabian, Philippine, and Caribbean plates. The map work alert is important. Memorize their positions north to south and relative to major continents, because prelims often asks arrangement or location-based elimination. What drives the motion is the engine inside Earth: convection currents. Internal heat sets up circulation in the mantle, and that circulation helps move the lithospheric plates above. The speed is slow but steady, about 2 to 15 centimeters per year, roughly fingernail growth speed. Toppers remember the scale because it prevents overthinking in answers. Plate interactions come in three types, and UPSC expects you to connect each with outcomes. Convergent means plates move towards each other, leading to collision and destruction. Divergent means plates move apart, leading to spreading and creation. Transform means plates slide past each other, dominated by friction. The key line to hold is this: plate boundaries are the dynamic zones where geology happens. At convergent boundaries, you typically get a subduction zone. The sinking plate bends and creates a deep ocean trench. As the slab goes down, conditions help generate magma that rises and forms a volcanic arc on the overriding plate. If you can point to trench, subduction zone, and volcanic arc in one diagram, you are covering multiple prelim statements in one go. At divergent boundaries, think creation. Plates pull apart, magma rises, and a mid-ocean ridge forms. This is where new lithosphere is created continuously. Keep the concept check tight in your head. Divergent boundaries create crust. Convergent boundaries destroy it. Many MCQs are just this idea in disguise. Transform boundaries are different. Here, no crust is created or destroyed. Plates slide, stress builds due to friction, and when it releases, you get earthquakes. So if the question hints at frequent earthquakes but no major volcanism and no crust formation, transform boundary should immediately come to mind. Now link this back to how the theory developed. The precursor was continental drift in 1912, associated with Alfred Wegener. The idea was simple. Continents were once united and then drifted apart. But the flaw was equally important. Wegener could show what happened using jigsaw fit, but he could not convincingly explain how it happened, meaning the mechanism was missing. Wegener still had strong evidence, and you should remember it as 4 proofs: jigsaw fit, fossils, rocks including placer deposits, and paleoclimate. Fossil distribution like Cynognathus, Lystrosaurus, and Glossopteris appearing across separated continents was a major clue. In prelims, they may not ask the whole story. They may just ask which fossil is linked with drift-type evidence. So keep these names associated with the idea of former land continuity. The missing mechanism came later with seafloor spreading in the 1960s, linked to Harry Hess and the conveyor belt idea. New crust forms at ridges, and as it moves away, old crust eventually recycles at trenches. Once you see ridges as sources and trenches as sinks, plate motion becomes logically unavoidable. That is why plate tectonics is called the unified theory. Continental drift gave the idea, seafloor spreading gave the mechanism, and together they form plate tectonics theory. Summarize it like this. Lithosphere is segmented into rigid plates. Plates float on the semi-fluid asthenosphere. Movement is driven by internal heat through convection, and interactions at plate boundaries create or destroy crust. Now you're exam ready. Thank you.